Hello, welcome dear children. So, I am here with you all today with atoms and molecules, chapter 3, class 9. So, straight away we are moving to our main points and topics, that is atoms and molecules. So, what is atom? Atom is the smallest particle of an element that can take part in a chemical reaction, may or may not have independent existence, and they are all retaining their properties. So, this is mainly the definition of an atom. So, atom, they may or may not have independent existence. That means, some of the atoms, they are already stable, they have the stable electronic configuration, and they are having the stability and have independent existence. But some of the maximum of the atoms, they are not stable, they are not having the stable electronic configurations. So, in that case what happens, they either gain or lose electron in order to attain the stability. So, here atom may or may not have independent existence and they retain their properties. This is all about the atom. Now, we will see what is molecules. Molecule is also a smallest particle of an element or compound which have independent existence and they take part in chemical reaction and they show all their properties, they show their properties. So, molecules, they are being formed, they are stable and they are having independent existence. Now, straight away we are going to the main part of this chapter, which is our main concern, that is the law of chemical combinations. So, whenever we are dealing with chemistry, we see different reactions are going on around us. So, how it is possible? So, all these reactions, whatever is being taking place around us, they are being governed by certain rules, certain principles, and with following this particular basic rules, the reactions are being carried out and we are getting or we are seeing different kind of chemical reactions taking place throughout the globe. So, first of all, among the law of chemical combination, first one we will see is the law of conservation of mass. So, what is law of conservation of mass? Mass can neither be created nor it can be destroyed, but it can be converted from one form to another. Whether it is in mass, energy, whatever in the universe, it cannot be created, neither it can be destroyed. We cannot destroy it, neither we can create it, generate it, but transformation is possible from one form to another form. So, this is the law of conservation of mass. So, during this law of conservation of mass, whenever, for example, suppose calcium carbonate, a compound of calcium CaCO3, that is calcium carbonate. Whenever we heat this calcium carbonate, what we get is that we get calcium oxide and carbon dioxide. So, now how can we determine or how can we say that before the reaction and after the reaction the mass is conserved, the mass is same. So, whatever is the mass of the reactant, after the reaction the mass of the product is also same. So, how can we prove it? So, to prove that we need to know the atomic mass. We will write the atomic mass, we will sum up the atomic masses of all the elements or atoms present in the particular compound, then we sum up, then we see the product, whatever we are getting the product, that also all the atoms we sum up the atomic masses. Then after that we will see that after and before, means the mass of the reactant is always equal to the mass of the product. So, this is also a clear indication that before and after the reaction the mass remains constant. So, This is the law of conservation of mass. We can see different examples also. Whenever any equation we see, whenever sodium sulphate reacting with barium chloride, what happens, and after that we are getting what? Barium sulphate and sodium chloride. So, in that case also we find that before and after the reaction, masses of the reactant, total mass of the reactant is equal to the total mass of the product, which is in accordance with the law of conservation of mass. So, this is what is the law of conservation of mass. Now, next one is that which is very important, that is the law of constant proportion. So, different compounds are being made always, every time, every day, and everywhere we see always different kinds of compounds around us. So, how they are being formed. So, in a chemical reaction, according to the law of constant proportion, in a chemical reaction, whenever the reaction is carried out, the elements which are involved in the reaction, which are combining to form the compound, means they are combining in a definite proportion by mass to form the compound. That is, whenever the elements are combining during a chemical reaction, they do so in a fixed proportion. Elements are always in fixed proportion. So, this is the law of constant proportion. Earlier we have seen the law of conservation of mass. Now, we see that the law of constant proportion. Now, suppose in the formation of water, what we see is that hydrogen and oxygen are involved as an element. So, hydrogen combines with oxygen to form water, but is it in any proportion or in fixed or definite proportion? Yes, this is in a fixed proportion. Whenever hydrogen and oxygen they are combining, always they are combining in a fixed ratio, that is either 1:8 by mass or 2:1 by volume, as we say. So, in case of suppose formation of carbon dioxide, carbon and oxygen are involved. So, in that case also we see that their ratio is 3:8 by mass. So, this is what, whenever we see that a compound formation is taking place, we should remember that the elements are combining always in a fixed ratio or fixed proportion. So, this is the law of constant proportion. Now, we have seen the law of conservation of mass, law of constant proportion. Now, how this next is about the Dalton's atomic theory, which the scientist Dalton, he has brought out some postulates, and that particular postulates in the first phase, whenever we are learning or we are going through any chapters of chemistry, we see that Dalton's atomic theory is somewhat relevant, but later part we have seen that in many of the points they were being corrected by different scientists with different discoveries and inventions. Now, we will see that what are the postulates of Dalton's atomic theory. According to Dalton's atomic theory, atoms are the smallest indivisible particle. The smallest particle of any matter is the atom. According to this is the first point what he has given. Next is a similar element or similar atom will have the similar properties, will have the similar mass, whereas the different atoms or the different elements, they are having the different chemical properties, different mass. So, whenever the elements are combining, they are always combining in a small whole number ratio, and they do so, the elements they are combining in a definite ratio. So, all these points Dalton have postulated in all his theories, and these are very important. First, we have seen what is atom, then we have seen what is molecule, then we have discussed about some that is the law of chemical combination, law of conservation of mass, law of constant proportion. Now, few examples can be given in this as a relevant part of this chapter, that is suppose a chemical compound is formed. Copper oxide was prepared by two methods. In one case 1.75 gram of metal gave 2.19 gram of oxide, and in second case 1.14 gram of metal gave 1.45 gram of oxide. So, in this case the given data, whether it is in accordance with the law of constant proportion, so you are to show. So, how can you show? You are to find out the ratio. Then if you can find out the ratio in both the cases, you can easily find out whether these data is in accordance with the law of constant proportion. Now, 4 gram of sodium carbonate and 10 gram of HCl is taken, they were reacted, and we are getting the product, suppose 2.5 gram of carbon dioxide and 11.5 gram of sodium chloride. So, is this data in agreement with the law of conservation of mass? So, this also you can find out how. So, in both the cases what you do is that you are to find out the masses of the reactant atoms. In the reactant side, masses, sum up all the masses of the atomic masses of the reactants, then you will find that it is matching or it is just same as that of whatever mass you are getting in the product side. If you sum up all the atomic masses of all the atoms in the product side, you will see that the mass whatever is coming out as result, it is same as that of the reactant side. So, in this way we can prove that this particular reaction is in accordance with the law of conservation of mass. Now, another question also can be there. Suppose we have taken a compound, and the compound, after the reaction we are getting the products. Now, as we have taken the compound, suppose we are heating it or mixing with some other elements or compound, and we are getting the products, whether this particular reaction is in accordance with the law of conservation of mass. So, in order to prove that, what you have to do is that you have to find out the atomic masses of all the elements first, after that of the reactant side and the product side, then you sum up separately reactant side and the product side. After that you can find out whether they are in agreement or in accordance with the law of conservation of mass. So, this kind of question you may get in your exam. Suppose we know hydrogen and oxygen is combining to form water. So, as we know that whenever they are combining in 1:8 by mass. So, in that case also, if what mass of oxygen can be used if we use 4 gram of hydrogen, this kind of question also can be asked. So, this type of question is very much relevant in these topics, and you are to practice it harder, more and more you have to take examples and practice to get the clarity of the particular topic and to have the basic idea and clear knowledge of this particular point, how this is being happening, how the rules are being applied to form the chemical compounds. So, that is all for now in this content. Thank you so much.